Hi guys, welcome to Unit 4, Lesson 4 notes on functions. I'm kind of impressed right now that we've gotten this far so quickly, so good job. By the end of the day, you'll be able to determine whether a relation is a function. So let's look at this graph. Remember when you're looking for the domain is all of the x values. So the domain is going to be all of these guys represented by our graph right here. On the other hand, the range is all of the y values. So the range is all of the up and down guys up here. You'll notice that this graph has a straight line. So we call this, this graph is linear because it's represented by a linear equation. Linear equations are equations that use two variables. You have x and you have y. You'll notice also that every single x you have has just one y that goes with it. So for each value of x, there is exactly one value of y. And you guys, that's our key idea of the day today. When we have a function is a relation that has only one y for every x. We're going to take lots of pictures today, lots of different visuals about what this looks like. So our key idea is that a function is a relation in which, in which each member of the domain, that is each x, is paired with exactly one, and one only, exactly one member of the range. Remember, domains is your x's and your ranges are your y's. Okay. So let's determine if each relation is a function. Well, we first have this relation right here. We have a bunch of different x's and we have a bunch of different y's. It's hard to tell from here, so we're going to make a diagram like this. I'm going to put all my domain in one group, and I'm going to put my whole range in another group. So in my domain, I have, I'm going to write them from smallest to biggest. I have -5, -2, 3, and 5. So that's my domain in a circle. Yeah, there. Like that. And then my range, I'm going to also write them from smallest to biggest. We have 1, 2, 3, and 5 represented here. Ta-da! Isn't that great? So great. Now let's match them up. 5 goes to 2, 3 goes to 5, -2 goes to 3, and -5 goes to 1. Excellent. So each member here has only one guy in the range, so yes, this is a function. Now let's look at B. They already drew the map out for us, so yes, this is a function as well, because each member of our domain, oh, that's the wrong color, oh no, oh well, each member of our domain is matched to just one guy in our range. Now I know what you're thinking. You're thinking, wait, but here we have a bunch of people going to 1. But that's okay. You're allowed to go this way. You're allowed to have ranges all represented by different domains. It's the idea here is that 1 only goes to one spot. It's not that 1 goes to 9 and 1 goes to 1. Then that would be a problem. Or if, 2 went to 1 and 2 went to 7, then that would be a problem. But the fact that each of these starting points only has one finishing point, that's our key idea. However, if we looked at this guy, here we have -1, -2, -3 maps up to 3, -2 maps down to, -2 maps down to -1, 1 goes up to 2, 2 goes down to -1, 3 also goes down to -1, and then, 4. 4 is our problem. 4 has positive 4 and -3. So this is not a function. This is not a function because you have two different y values for the same x value. That means it's not a function. You'll notice here, we can draw a vertical line through here and it'll intersect 2 points. That means it's not a function. Oh hey, that brings me to the vertical line test. The vertical line test says if you have any vertical line and it passes through more than 1 point, then it's not a function. That is, if any vertical line passes through no more than 1 point of the graph of the relation, then the relation is a function. But it's a lot easier to say like reverse. If a line passes through more than 1, then it's not a function. For example, if I were to draw a vertical line here, then this vertical line would only ever pass through our graph once, wherever it is. So this is a function because the vertical line doesn't ever hit it twice. Let's do number 2. Is this a function? Ooh, it's definitely not linear because it's curvy. However, as we move our vertical line, it still only ever intersects once in our function. So it only has an intersection like here. That's only 1 point. Okay? This point will move, right? So it's up here, intersection is here, but there's only ever one intersection. So that is still a function. However, if we move down here, if I were to draw a vertical line right here, for example, it would intersect twice. It intersects here and here. That's not allowed. This is not a function. Let's try one more. Ooh, look at this guy. This is a funky guy. Whoa, look at him. Well, let's do our vertical line test. If we've got our graph and we draw it, it's intersecting once. Intersects once. Ooh, no, this is a function. This is a function because it never intersects more than once. It always intersects just once. So yeah, this is a function. Ta-da! So not only can you determine if something is a function, you can actually evaluate the function. You can say, hey, what is the value of the function? For example, if we go here and we say, what is the value of the function at x equals 1, for example? It's really thick. What is the value at x equals 1? Well, that's the point, the height at which x equals 1. So if this were our function and we would say, well, the function of 1 is 3 because you plug in your x and then wherever your y is at that point, that's the value of the function. Ta-da! So when I say evaluate the function, you're basically just finding the height. How high would that function be at that point? So this guy right here, this f, this is the name of the function. Our function is named Fred. I'm just kidding, it's named function. So what is the function of x here? Well, whenever you have an x, you just plug your x in for x, you multiply it by 3, and then you add 5. So let's do that. Here we've got x is 4. So if f of x equals 3x plus 5, then we'll plug in x is 4. That means f of 4 is 3 times 4 plus 5. Notice what this does not mean. This does not mean you're doing f times 4. No, this is the name. We just want to find out, hey, what is this value? So we just keep hitting enter. So 3 times 4 is 12 plus 5, which is 17. There. So f of 4 equals 17. That's it. That's your solution. Saying, hey, what is the value of the function when x is 4? Well, when x is 4, y is going to be 17, or f of 4 is 17. So that would give you the point 4, 17, because that's your x and that's your y. That is, when x is 4, y is 17. Okay. The same process is going to be true no matter what f is. We still have our function. F is defined by 3x plus 5. So when x is -2, we just plug -2 in for x. So that means f of -2 is 3 times -2 plus 5. When we evaluate that out, we get -6 plus 5, which is -1. So f of -2 is -1. That's it. That's how you write your answer. Ta-da! This means that when we plug in -2 for x, it'll spit out 1 for y. Oh, sorry, not -1. It'll spit out 1 for y. So when x is -2, y is +1. So what were the steps we did here? First, we substitute x. And then we simplified. Guess what, guys? We don't even need a number to be our x. Excuse me. It can be a variable. Like over here in part C. That's fine. We just substitute 6a in for x. So f of 6a is going to be equal to, well, just wherever we have x, that's 6a. So it's 3 times 6a plus 5. Well, 3 times 6a, that's 18a. And 18a plus 5, we can't simplify anymore. So f of 6a is 18a plus 5, whatever that turns out to be. Great? Great. Well, that's nice, but when are we going to use this in real life? Well, let's say you're going on a road trip and you're going to rent a car. I was almost going to rent a car next week, fun fact. And you know the cost of a one-day car rental is given by the function c of x equals 0.18x plus 35, where x is the number of miles that the car is driven. So suppose that you drove 180 miles in one day. Oh, no, x is the number of miles driven. My bad. You drove 180 miles in one day. What is the cost of the car rental? Well, the cost is our function. That's basically our y, right? We just have to plug in x. And what is x? 180. Because x is the number of miles driven, and we drove 180 miles, we say x is 180. So now we need to plug that into our function. The cost of x is 0.18x plus 35. And what this means is when x is the number of days and we drove 180 days. So the cost of 180 days is equal to 0.18 times 180 plus 35. So this c here, this c, see this c? It's going out to c. This c is not a variable, it's a name. It's cost. The cost of 180 days. So we don't have to simplify this at all. We just simplify this side over here. And let's do it. So the cost of 180 days is 0.18 times 180 is 32.4. Plus 35 is plus 35, which comes out to 67.4. But in the context of the problem, what did C mean? Well, C meant that's the cost of the rental. So the cost of 180 days, the cost to rent a car for 180 days is $67.40, and you guys, that's super cheap. So I don't know who wrote this or what company this is, but definitely take up that order. Okay. So if you want to evaluate a function, you need to substitute x. Oh dear. You need to substitute x. And remember that the function is not a variable, it's just the name of the function. So the function of 6a, or the function at -2 is, or the cost of whatever. This is just the name, that's it. Oh, and your vertical line test. You need only one matchy guy. Each x only goes to one place. It does not go to two places. You have a fantastic time on your homework. Oh, you guys, put the fun in function.